This was the An-225 Mriya, the dream. For over 3 decades, it was the undisputed sovereign of the skies. The world's largest and heaviest aircraft, a 6-engine strategic airlift titan so immense that it made every other plane look small. To stand beside it was to experience a failure of human perception. Its 275-foot length stretched beyond the limits of a single glance. This wasn't just a large plane. It was a flying infrastructure project, a machine built for one monumental purpose: to carry what nothing else could. Its sheer scale starts with the wings. With a span of 290 feet, they stretched wider than an American football field, including both end zones. This vast expanse of engineered aluminum covering nearly a quarter acre was the only way to generate enough lift for a maximum takeoff weight of 1.4 million pounds. To put that in perspective, imagine stacking 160 family sedans into a single machine and asking it to fly. Those wings made the impossible a reality. But wings that grand created unique challenges. The wingtips extended 145 feet from the cockpit, creating a massive blind spot. The solution was a cockpit perched high on the nose, a command bridge offering a sweeping view. But even this wasn't enough. The An-225 moved with an entourage of human wing walkers. On the ground, their eyes tracking clearances no camera system could guarantee, a testament to a machine that had outgrown purely technological oversight. The tail was another radical departure. A standard airliner uses a single vertical fin, but the An-225 was born to carry cargo on its back, which would disrupt airflow to a central tail. The ingenious answer was a twin-tail design. 2 vertical stabilizers, each 6 stories tall, mounted at the ends of the horizontal stabilizer. This H-tail kept the control surfaces in clean air, providing unwavering stability whether the fuselage was bare or burdened with a space shuttle. Beneath those colossal wings hung the heart of its thunder. 6 Ivchenko-Progress D-18T turbofan engines. Each engine produced over 51,000 pounds of thrust. Together, they unleashed a combined force of nearly 310,000 pounds. For comparison, a Boeing 747s for engines produce about 266,000 pounds. The An-225 generated over 16% more thrust, and it needed every single ounce. The magic of these engines is their Hibipus design. Think of the giant fan at the front like a hyper-powered room fan. About 85% of the air is just accelerated by this fan and bypasses the hot engine core, producing most of the thrust efficiently. Only 15% of the air is compressed, mixed with fuel, and ignited. For moving mountains, you don't need a blowtorch. You need a hurricane-force leaf blower. That 15% of air that does enter the core goes on a brutal journey. It's squeezed through 14 compressor stages, ramping up the pressure to 24 times that of the atmosphere. This superheated, pressurized gas then mixes with jet fuel and ignites, creating a controlled inferno reaching 2,900 degrees Fahrenheit. The expanding gases spin turbines that drive the massive front fan, completing a cycle of breathtaking power. 6 of these working in concert could accelerate a small apartment building to flight speed. Such power demands a prodigious appetite. The An-225's fuel tanks held 96,000 gallons, enough to fill 5 backyard swimming pools. At cruise, the 6 engines would collectively drink 4,200 gallons per hour. This vast capacity granted a range of up to 8,300 miles when lightly loaded, but fill its cavernous holds to the maximum, and that range shrinks to just over 2,000 miles. Demanding careful mission planning. The genesis of this colossus lies in the Cold War space race. The Soviet Union Esperon shuttle program faced a logistical nightmare: how to transport completed orbiters to the launch site. The existing An-124 transport wasn't enough. So, the Antonov Design Bureau took the An-124, stretched the fuselage, expanded the wingspan, and added to more engines. The result, the An-225, first flew on December 21st, 1988. Just months later, it carried the Buran shuttle on its back to the Paris Air Show, creating an iconic image that stunned the world. While carrying a space shuttle is its most famous role, the An-225's true mastery was revealed inside. Its cargo hold was the largest enclosed volume ever designed to fly. At 142 feet long, it could swallow 16 standard shipping containers. This space existed for cargo that defied any other mode of transport: 150-ton power plant generators. industrial turbines, 2 large 4-rail tunnels, and emergency relief supplies that would otherwise require a whole fleet of smaller planes. Loading such monumental cargo required engineering theater. The entire nose section hinged upward on massive hydraulic actuators, yawning open to reveal the hold. But moving a 200-ton object up a steep ramp is dangerous. So, the An-225 had a kneeling system. Hydraulic rams compressed the nose gear, tilting the entire aircraft forward. This lowered the cargo floor, flattening the ramp angle and making the impossible possible. Inside, the hold floor was a masterpiece of low-friction engineering. 2 heavy-duty rails ran its length, and between them, thousands of freely rotating steel balls were recessed into the deck. A load weighing as much as a locomotive could be pushed into position by just 2 people. This system allowed for minute adjustments, ensuring perfect placement for weight and balance. Critical factor in heavy-lift aviation. An unsecured load shifting mid-flight could be catastrophic. The maximum internal payload was a staggering 551,000 pounds, more than twice what the U.S. Air Force's giant C-5 Galaxy can carry. The airframe itself was a triumph of aerodynamics. The wings used a special supercritical airfoil to reduce drag at high speeds. For takeoff and landing, the wing transformed. Slats on the leading edge and massive flaps on the trailing edge extended, increasing the wing's area and curvature. This allowed the An-225 to maintain lift at speeds that would otherwise cause a stall. Controlling these huge surfaces required immense force from triple-redundant hydraulic systems. Then there were the wheels, 32 of them. A 1.4 million pound aircraft would punch through runways, so the solution was to spread the load across 28 main wheels and 4 nose wheels. This resulted in ground pressure lower than that of some smaller jets. Each main gear leg had advanced shock absorbers that could compress up to 16 inches, making the ride smooth even for the most delicate cargo. The An-225's operational history is a chronicle of broken records. In 1989, it took off with the Buran orbiter on its back, a combined weight of 1.23 million pounds. In its commercial life, it set records that still stand, including the heaviest single item ever, airlift ETA, 247-ton generator. It became a symbol of global heavy-lift capability, responding to emergencies and enabling engineering projects worldwide. Tragically, this dream was shattered by war. On February 24, 2022, the one and only An-225 Mriya was undergoing maintenance at Hostomel Airport near Kiev. During the intense battle for the airport in the opening hours of the Russian invasion, the aircraft was caught in the conflict and destroyed in its hangar. The world's largest aircraft, a symbol of engineering, audacity, and peaceful capability, was reduced to ruins. An unfinished second airframe exists, about 70% complete, but estimates to finish it exceed $800 million. And much of the specialized knowledge and supply chains from the Soviet era are gone, lost to time, retirement, and war. The An-225 Mriya. The dream flew for 33 years. It was proof that humanity could build and master machines that stretched the very laws of physics. It turned the impossible into routine. Its destruction is a stark reminder of the fragility of our greatest creations. It was more than an aircraft. It was a soaring cathedral of engineering ambition, and its absence leaves a silent, unimaginable void in the skies it once ruled. Thank you for watching.